Hello everyone. I hope you can hear us, and thank you for coming first of all. And this is our new initiative, and it is meant to like direct the freshers or experienced people towards the right way of approaching the towards clean energy. As you know that we have already mentioned that the topics of webinar will be covering the needs of solar PV simulation softwares in the industry, how it has evaluated the market in the perspective of technicalities and commercialities, as well as like we'll discuss about the opportunities that what a person can avail as an opportunity post getting expertise on these softwares. So first of all, I'll explain you the features of this webinar. Like there are several sections over there. If you can see on your webinar tab, there is one polls sections in which one question has been asked. So you can give a poll post this webinar. There is the questions section where you can put your questions in between the webinar so that we can raise to our speaker. There are handout section in which we have included 5 of the knowledge material, like some of the PDFs regarding the floating solars and designs and the market reviews from the popular magazines. And there is a chat section in which you can send us the questions as well. So today's speaker is Mr. Ram Perumal. He is from Chennai. He has been an ex-worker of Sun Edison, Breton, California, and he has been moved in India like from last 1 year, and he has been working with several Australian companies and European companies as well, and has an experience of 1 megawatt of designing, including off-grid, on-grid, and single access tracking system. So Ram will be taking the webinar forward, and you can ask any questions in between. I'll be the mediator in the webinar. Ram, you can start.
So, good evening, good afternoon, good morning, everyone, for the very first webinar today. And I am Ram Perumal, and I work as a freelance design engineer. And before starting as a freelance engineer, I used to work for Sun Edison as a performance and development engineer. So during my time at Sun Edison, we used to work closely with the sales managers. So once the project comes in, we take care of the project right from engaging with the customer right until the whole construction starts. After which the EPC company takes over. So before working for Sun Edison, I used to work for a very small residential company called Second Generation Energy, which was based in Massachusetts, US. So there it was pretty much similar, but the projects were on a smaller scale. Let's say, for example, anywhere from 1 kilowatt to say about 15 or 20 kilowatts on the residential scale. And before that, I did my master's in the US. I did MS in solar energy engineering, and I have an undergrad in instrumentation control engineering from Chennai. So this is the background of mine, and and again, welcome you all to the very first webinar. And I've thought of a small approach for the whole session today. What I thought is I just go over a small process that most companies follow in terms of design. Right, as an engineer or as a design person in a company, this is how I see the whole process move from section A to Z of a project. And then this is like the backbone, but certain companies have their own formula to move from one stage to another. But this is like the whole structure. But moving it here and there depends on how a company prefers. And we want to talk about how we could combine all these and how the tools that are being taught in Solware help you all with the whole process. So just let me know if I'm going a bit fast or if you're not able to, if I'm not clearly audible, just let me know. I'll slow down a little bit or say a little so everyone understands or hears me clearly. So first thing, what I would like to show is I would like to share my screen and then show you a small design that we did for a rooftop project. And before that, I would like to explain how the whole process moves in the company I work for. So what happens is Every company has a set of sales managers or sales guys who look at, let's say for example they are constantly in search for any new projects or opportunities or tenders and things like that. Right? So once they find something that is in of their interest, let's say for example we are a company who do grid connected systems and rooftop systems anywhere in the range of say 1 kilowatt to say about 100 kilowatts, and there is an opportunity out there. So what happens is the sales guy would take the whole tender document, or sometimes it's called as RFP. So what they do is they take the whole document and then go over the whole details, looking at okay what all should be included. Let's say for example if there is a tender out there by the government of Tamil Nadu. So what happens is they might have certain requirements there, stating that the modules and inverters should be like Indian made. There should be there could be like a 80-20 percentage of employees or the projects being procured and things like that, right? So what happens is the sales manager would take care of all these things, and then when it comes to technical details, he would push it to the design team, right? The sales managers might be equipped well enough to understand what the technical details mean, but still the engineers should also understand or know what are all the nuances within the project. Right? So what happens is, as an engineer, we also go through the whole tender document, or at least the technical part, so that we understand what needs to be provided, right? Because sometimes the sales managers, the sales guys might overlook certain details, which they might think that it's the same for all the projects, but there might be small nuances that the engineer needs to take care of. So we also go through the whole design and then we plot on okay what needs to be done, right? So this is how the whole reading a tender document goes in. And then once this is done, we start with a preliminary design. Let's say, for example, we have a plan set or a satellite image or a site image, something like that. So what happens is we do a site layout, a very preliminary layout, saying that okay, this is the overall size that we put together, and this is how big a system we could install here, and these are all the obstructions and these are all the problems we might have in the project. So once we do this, we have a layout or we have like a site plan that says, okay, this is how big a system we could install, and then once this is done, we need to understand how much energy this system puts out. That's where the energy estimation tools like Helioscope and PVSyst. And there are a couple of other tools in the market, but for now, let's just stick to Helioscope and PVSyst. So these two tools help you predict how much energy the system that we designed is going to put out together. Right? Because the customer is consuming at a certain rate, and we have a system, we have a preliminary system that we think we can put on this customer's rooftop. So now we need to understand how much energy we can offset from the customer's overall consumption, so that we save them some money because of going for solar. So once this is done, let's say like we are done with the preliminary design, and then we have like an energy estimation report. So once these two are done, and then we do something called as costing, right? Um, let's say for example you're using a 300 watt module, about 10,000 10,000 modules and wires and inverters. So we come up with a whole pricing that includes all the components and also the installation cost. So these three are done, and then that's only when these three are done, we could move on to the savings analysis, where both the cost of system and also the energy that the system produces come into play. We can have a layout, but without having an energy estimation report, which states how much energy we're going to generate at this particular project, we won't be able to do or provide any savings analysis to the customer. So let's assume section A to be the design phase and section C to be the costing phase. Section D need to be the energy estimation phase, which kind of takes details from A, processes all those, and then sends it to section C, which could churn out a savings analysis or any output that could be proposed to the customer or sent out to the customer in order to have the project executed. So
Hello,
so this is,
hello.
yeah, yeah, go ahead.
Ram, your voice is letting it's creating amplification. So just check if it is connected to your CPU. I guess it is creating some noise.
Okay, hold on 1 second.
Is it clear now, or is it still yours?
Yeah, it is clear. It is pretty clear now.
Okay, okay. Yeah, sorry about that. Okay, I didn't realize.
Hmm.
So, I hope we didn't have a lot of disturbances, that you didn't hear any
No,
of
no,
what I
no, not an
said
issue.
now.
You can carry forward.
Okay, okay. So this is a small intro towards how the tools that we have in this course are going to help with the design and the whole processes. So what we'll do is I'm going to show over a small design, that is the section A that we discussed right now, which is a layout that was put together using different tools. And then I'll just go over what we did there, and then let's talk about the energy estimation part. Let me Hey, Abhimanyu, could I get the control?
Yeah, just a second. I will give you the control.
Thank you.
Are you able to share?
Hold on one second.
Okay.
I'm gonna stop sharing my webcam for a second. I'm gonna start sharing the screen. Hey, Abhimanyu, I still don't have the presenter rights. Could I get the presenter rights, please?
Okay, I've shared you the rights as well.
Okay.
Just check it now. Yeah.
Right. Right. I
Hmm.
have the presenter rights now. Can you guys see my screen?
Yeah, it is visible.
Okay. Okay. So is everyone able to see a rooftop design?
I am right now able to. We'll ask candidates who can put a question over there or share a consent in a chat box if you are able to see that or not. I guess it is visible now.
Okay, okay. So, so if this is a layout that we did for a 2 megawatt rooftop system, and
Hmm.
so what we did is this is based on a satellite image. So the customer was interested in going for solar, and this information and this lead was got to us by a sales manager. So we thought we'll put together a design for them, and all we had is your energy bill and the site address. So since the satellite image was pretty good, we were able to go over the whole design process just by using the satellite image. And as you could see, all the scaling and everything is done from the satellite image. And we thought, okay, this being a large rooftop, and since we didn't have to go for a system that covers the entire roof, we could play around with a lot of offset. Let's say, for example, we were able to provide a 15 feet boundary offset from the edge, so which is not possible in all the projects. Sometimes we might have to go as close as say about 1 meter or 1.5 meter, so that you are able to put in a good system size on a rooftop. So what we did is this design was done using SketchUp and AutoCAD. So we have to draw all the abstractions in. So this had to be done. Say for example, we bring in the image from Google Earth, we put the thing in, and then we draw all the abstractions here. We try to estimate what would be the height of each and every abstraction. Let's say, for example, if it's a AC unit, it's probably between 4 to 6 feet, depending on the size of the HVAC unit. If it's a residential unit, it's somewhere between 3 to 4 feet in height. If it's a commercial unit, sometimes it might go until like say 8 or 10 feet. Yeah. So we draw all the abstractions in here and then try to apply a shading profile depending on the site and how big a system we want to go. Let's say, for example, if there is a requirement from the customer saying that you don't want to see any shading between 8 o'clock in the morning to 4 o'clock in the evening, then obviously we need to change the shadow analysis timing. Right now I have set the shadow analysis timing between 10 to 2 p.m., 10 a.m. to 2 p.m. But if we want the window to be much larger, we can definitely do that. So we make sure that none of the PV modules are being shaded during the day. So this is the very first part, right? So what happens is, let's assume we do not stop just placing modules here. We want to place modules on throughout the roof. So we place all the modules, and then this layout part is one that's going to give us an idea of how big a system we could install here. Let's say this is a 2 megawatt system. Probably we can add in 1.5 megawatts more. So let's say this was going to be a 3.5 megawatt system, right? So that is the detail, that is the information we take from this section, and then we note it down, or we pass it on to the person who does the energy estimation. So what I'm assuming is, in certain companies, this part of putting a layout together is taken care of by a drafting team, and then the energy estimation part and costing is all taken care of by a different team. But in the company where I work for, we were taking care of the entire process, right from putting together layout, getting the energy estimate done, and then providing costings and savings analysis to the sales manager. So, so this is the layout part. I would like to show you another layout of a carport system. This is a rooftop. I'll just show you a canopy system that was put together in a similar fashion. Right. I hope everyone is able to see a different layout now. So this was a parking lot project where they had quite a lot of space for the modules to go on, and then they had a lot of parking spaces. They didn't have any space on the roof, as you could see. The roofs are
Ram,
yep.
one second. Just minimize your right hand side button so that the image will be clear fully.
Okay, cool. Thank you. So as you could all see that this is all the roof space they have, and you could see it's not a lot, right? Especially for what the customer consumes every month or over the year. This is not a lot of space for them to have a larger system. That's where we thought we could go for a carport system, which solves two purposes, right? It also provides shade for all the vehicles there, and in addition to that, we are able to put a much larger system, and we're able to offset a lot of sort of energy that the customer is consuming over the year. So that's where we would go for a carport system like this. So any project, as I mentioned, starts with a layout that gives us an idea. Sometimes when we don't have time, we could go for a ballpark number saying that, okay, this is the square feet of the customer's area, and this is we have like a ballpark number saying that, okay, let's do we could be able to place say 400 modules or 500 modules, and then you just multiply that by the wattage of the module that you usually use in the design, and you can give them a ballpark number. But when it comes to a sales phase, that is not going to fly. We would have to have a design so that we are confident on how big a system we could install there. So this is the initial layout phase, and then we'll move on to the energy estimation part, which is the whole core of the session we'll be having today. So what happens is, Once you have done the layout, there are certain things that we need to take into account, right? The first one is all the details that we gather from the layout. For example, the total number of modules. Once the layout is done, there are certain details that we need to take and keep it on record. So, for example, the modules that we have used, the number of modules, and what direction it's facing, what's the tilt of the modules, and things like that. And then we also take into account the number of inverters that we would need for the system. So we take a note of all the equipments that form this design. Once this is done, we move on to the energy estimation phase. And let me open up a PVSyst report so that you can take a look at the whole report, and I'll tell you where and how this one helps the whole design process. Is everyone able to see the whole PVSyst report, the very first page of the PDF?
Yeah, it's visible.
Okay, okay. So this is how a typical PVSyst report looks like. The very first page has, if you look at the top here, you can see that we have all the information. Say for example, the location details, right, where the site is located, and once the design is done, there is a very important part we need to take care of, which is the weather station detail. Say for example, if we are designing a project, say somewhere in and around Chennai, then we would have to take the solar insolation detail of Chennai for that particular project. But let's say if we have a project that doesn't have any meteor station close by, then what happens is we would have to depend on other tools, say for example Meteornom or Solar Anywhere, which has a different algorithm that uses insolation detail for that particular site. Right? There are a few free resources and there are certain paid resources. It depends on the project that we go for. Let's say if the project's overall cost is about say 3 to 5 lakhs, we don't want to spend about 2 to 2 lakhs for meteor station data. But if it's a utility project where you spend crores of money there, then spending a lakh for getting an accurate data doesn't affect the project's financials. So that is where we make a decision on which data source we need to go for. So once that is done, we once that is done, we enter all the details. We say what the tilt is, what is the distance between each and every row, what module we have used, what inverters we have used, and all the details. So this is where PVSyst has a section where we're able to enter all these details. And once we're done with that, we can go for the final simulation where you'll be able to see the whole loss packet. Right? So the page before that, I'll just show you what happens here. Right? We enter all the details in, and then we run the simulation. So what happens is PVSyst is going to give you the product produced energy for that particular year. Right? So let's say we have a system of 365 kilowatts, and then we enter all the details, and for that particular project, this is the energy we are going to generate. Right? So this is the overall annual energy, and we are also able to see the monthly energy generated over here. It's like 35.64 megawatt hours for January, 32.54 megawatt hours for December, and 579.98 is for the whole year. So this is the detail we get from PVSyst, and this is what we would be using for the savings analysis, right? To understand, okay, what happens here. Now, let's say, for example, the grid over here, if we are consuming certain megawatt hours in a month, we could only offset that. Let's say, for example, in January, this particular system is just generating 35.64 megawatt hours, whereas the customer is consuming only 30 megawatt hours. So what happens is this 5.64 that is being left over is served as a credit to next month's consumption. Right? Let's say next month we are generating 37.13, whereas the customer is consuming say 42.1. Right? So he is consuming 5 megawatt hours more. So what happens is whatever we generated on the previous month, which is an extra, is applied towards next month's offset. Right? In the way, what happens is this is the number we have for the system's overall annual generation. We would look at the customer's electricity bill and understand what he consumes on a particular year, And then we try to size a system saying that, okay, this is how big a system we would need for the customer to offset 100% of his energy. I'll show you another number in here. So when we look at PVSys, there are two numbers which PVSys gives us. I mean, there are a lot of numbers which PVSys gives us, but these two are supposedly the numbers that helps us with sizing a system. Right? So we are able to generate 580 megawatt hours per year, and then there is something called a specific production. Right? So what this number means is this is 1579 kilowatt hour. So what this number means is for every kilowatt of system size, this is the energy we would be able to generate, right? Let me open up the calculator to show you this. So what happens is we have a specific production of 1579, right? So I have 1579, and my system size is 367, right? 367. So you get 579.493. This is the kilowatt hour. So I'm just going to divide by 1000, right? So my overall system generation is 579.49. PVSys has rounded up this value because system size is slightly more than 367.12, something like that. So my overall system generation is 579.49. This now you could use, for example, once you run a PVSys report and then you get this number, you would be able to go back and find out the required system size for your consumption, right? Let's say the customer has an annual consumption of 300 megawatt hours, right? So enter 300. I'm going to convert this one into kilowatt hours. I'm going to multiply this by 1000. And I know this 1579 is the specific production for this particular system. So I'm going to divide by 1579. So I get a number saying that it's 189.9. So I'm going to call it 190. So what this means is, I know for this particular system, which has 340 watt module, a 28 kilowatt inverter, a 12-degree tilt, and a 170 azimuth, at that particular site, let's assume this to be Chennai, all I would need is a 200 kilowatt system to actually offset the entire customer's consumption, right? So this is why PVSys helps us. We get the energy generated, and then we get the specific production numbers that we can use to offset the overall consumption that the customer has, right? So this is the more important part that goes on to the sales phase or the cost analysis. But PVSys also gives you a whole loss diagram, right? When you look at this diagram, it kind of gives us a flow of all the losses we have in the system. This is the overall energy that's falling on the flat surface, and this is what is falling on the module, and then you have a couple of different losses, right? Since we have modules in a row, there is a near shading loss, and then there is going to be spoiling. There is going to be dust falling on the module, so you have a certain loss for that. And then there are other characteristics in the module that gives you like a temperature loss. What happens is as we all know, sun has two components, right? Sun's energy has two components. One is the light, and other one is heat. With the PV modules, we only utilize the light energy of it. We don't use the heat energy of it. But what happens is during the afternoon hours, the overall ambient temperature is higher, so that modules energy kind of degrades to a little bit. Right? That depends on where you are. Say for example, if you are in a very hot region, you would have a temperature loss around this value, like 10% or 12%. Whereas if you have a project somewhere in say Shimla, where the ambient temperature is much lower, so you would not see a loss of 8.8%. You might see something like say 4 or 3%. And then this also depends on what module you use, be it crystalline or thin film modules, but you would have this loss, but it really depends on where you are and then what modules you use. Once that is done, we have all the losses, efficiency loss of inverters and things like that. So this is a whole loss diagram, and this value comes from whatever details we enter here. Say for example, temperature losses and ambient temperature, all the detail, whatever we enter there goes down as a final loss, and this is the energy the system is going to produce. So what happens is PVSys kind of makes you enter all these numbers. We could just enter a certain value elsewhere, like whatever value we have, and PVSys applies a particular loss wherever it has to go, and then it gives us a final generation number. So this is what we have with PVSys, And then what I'm going to do is I'm going to open up the other topic that we are going to go a little bit over, which is Helioscope. I'll tell you the difference between PVSyst and Helioscope and how Helioscope takes care of the energy estimation part. So yeah, let me open up Helioscope report now. Okay. So I assume everyone is able to see my Helioscope report. So what I'm going to do is I'm going to zoom in a little bit and show you how the Helioscope report looks like, and then I'll just explain what we did here and what is the difference between PVSyst and Helioscope. So this is how a Helioscope report looks like. And as you can see, this has similar details. It has the project name, address, system size, AC system size, and whatever energy we generated for that particular year, and all the details here. And then you have a similar graph which says monthly generation, and then whatever losses you saw a loss graph in PVSys. That is similar to the loss graph we see here in Helioscope report. And then we have information on all the details that we entered in, and then the string sizing and things like that. The one that you did not see in PVSys is a layout like this, whereas in Helioscope you are able to see a layout. Right? So this is the main difference that we have between PVSys and Helioscope. So in Helioscope, what happens is you are able to start with a layout. Helioscope is a browser-based design tool. So what happens is you are able to design a whole system starting from layout, and then you can generate energy for that. What happens in PVSys is that it doesn't have an option for you to go and design a layout within PVSys, right? If you have a design already done, you can import that into PVSys, but you cannot start with a design in PVSys. But whereas in Helioscope, it has inbuilt API towards Google Maps and Bing Maps and Nia Maps and all the mapping tools. You can also import any plan sets you have. For example, let's say there is a project which doesn't have good satellite image, but you have a plan set of the whole project. So you can import that particular detail in, and then you can mark the boundary, and you can start placing your modules and do the whole design. Right? Once you get the layout done, since it's within Helioscope, it automatically understands what module you have chosen, what is the space, what is the gap between each and every module, how many modules are there in each and every region, and then it runs a simulation for you, and then it gives you a final generation production report, which looks something like this, right? So like we saw in previous years, this also have like a system loss diagram. A chart there you can see temperature difference like 7.8%, soiling is like 2%, all these. And you are able to control a lot of things here, let's say for example you are at a place that has a lot of soiling losses, so a 2% soiling loss does not go well there, so you are able to go change these numbers, and then you are able to say for example if you want to use a different optimizer, a different string size, you are able to do that, and you're able to define what modules are using, what inverters are using, how many inverters, and what is the string size, and all the details there, and everything gets built in, and then you get a final generation number, which looks something like this. So you have like a monthly generation report, and then an overall energy report for the whole year. So this is the main difference between Helioscope and PVSys. Whereas in PVSys, it is a standalone tool. So for example, if I have something installed on my system, it's installed on one system. You won't be able to access it from a different system. Right? You can have it in a network, that's a different story, but it's like a system based. You have to install it in one system. And in Helioscope, it's a browser-based design tool. So all you need is a login ID, just like Gmail or any mailing tools. So if you have access to internet and a browser, you can log in and change the design. So this kind of gives you flexibility where a single license for the whole team is good enough unless they are trying to open it up at the same time, right? Let's say for example there are three design engineers who are working in different time zones, so you could have like one design one a login ID, and they could work on the design, and it stays there for everyone to look at. Let's say for example engineer A is working on a certain project, and if you want engineer B to go check it out, after some time, they can just log in and you can open the project and you can check it out. You don't have to wait for the engineer A to send all the details to engineer B to take a look at it. So which kind of makes it very easy for the whole company, right? It's out there for anyone to take a look at it. If they want to make any modifications, they can definitely do it without having to wait for the first engineer to send the details. And like when we look at this, it might look like Helioscope is like the whole tool for energy estimation. But when it comes to doing a whole design, just for energy estimation aspect, PVSyst has a bit more details that Helioscope that cannot do. Say, for example, when we look at single axis tracker systems, PVSys is able to handle a larger system. You don't have to have a size limit of say 5 megawatt. We can go up to say 20 or even 100 megawatt system. We can simulate as big a system you want. Whereas in Helioscope, since it's browser based, we have a certain limitation at this point, but they are trying to overcome all those and stay in par with any other estimation tools. So there are certain advantages that in Helioscope that PVSys doesn't have, and then there are certain advantages in PVSys that Helioscope doesn't have. So it's for us to make an educated decision as to what tool would be best for our everyday design processes. So this is the whole overall of both the tools, and I would like to open up for any questions. Hope I wasn't way too fast. I just want to know if you have any questions, and happy to talk about that again.
Hello.
Yeah.
Yeah, Ram, there's one question. It's specific to state Gujarat.
Okay.
So it is asked by Ponkya Jaydev. So he is asking that what are the price per unit to sell power generated from solar specific from Gujarat?
So it depends on the options you go for, right? We have a so you come up with a project, and you have the whole cost analysis done, and then you go for the tender, and that's where the utility decides on at what rate they're going to buy the energy from you from. Right?
Okay, Ram, we can also orient them about the step robotics application, how one can use the mobile application to design.
Okay. Okay. 1 second. Hold on 1 second. Okay. I'm gonna go over the very first tool that we use for shading analysis, and then I'll slowly move on to what we could do with step robotics here. So can everyone see my screen now?
Okay, I guess your screen is.
Yeah. Yeah, I have the Solmetric Sana. I just wanted to give you a intro onto this and then move on to step robotics, so that we could see how step robotics is much advanced than what we have with Sana here.
Sure.
So Because what happens is when we get a lead, it always starts with a design. But to have a design, sometimes even if we have a satellite image, that might be outdated. Right? A satellite image might be outdated by say 5 years or sometimes even 10 years. So in that case, whatever we see on a satellite image may not be accurate, and we cannot have a final design based on that. So in those cases, we always make a site visit. That's where we go there and then we try to make measurements of every single thing. Let's say, for example, we have like a vent pipe or even a and whatever it is, we try to take those measurements and then bring those measurements into the layout, so that we are able to make a good shading analysis and make sure that we don't have any modules on regions that are being shaded. So in that case, there are certain tools out there, and in terms of measurement, we don't have to worry about anything. But when it comes to seeing if the modules would be shaded, it's going to be very difficult for us to visualize just with the height of the abstraction. We can go with the ballpark number saying that the abstraction is like say 1 meter, the shade is going to be, we need to stay away for 2 meters. We can do that sort of thumb rule, but to have accurate shading analysis, we would like to utilize tools like this. Soulmetric Sun Eye is a tool that's like it's a handheld device. It's like a multimeter, it's as big as a multimeter. But what happens is it has a fish eye lens and then a GPS oriented towards it. So what happens is when you take it to a particular location, it knows where the location is. It knows the exact latitude and longitude, and then it takes a picture with the sun eye fisheye lens you see here. So you see a fisheye lens here. It takes a whole picture, and with the GPS, it knows the exact path of sunlight. Let me try to open up, show you what. So So what happens is it predicts the whole path of the sunlight. You can see the path here. So you can see a globe. It says, okay, this is the you could see timings from 12 o'clock, 2 o'clock, 4 o'clock, or 6 o'clock, and then it also has months. So for example, the lowest end, this line corresponds to December, and then this line corresponds to July. So all of the months in between. So this is the picture that is taken on the site using this tool, and then it gives you sun's path. And all the trees you see here, let's say for example, this tree over here, this tree and this tree, are all going to shade the modules at that particular location, right? This shading analysis is done with Sunlight so that you are able to see certain, for example, when we go there and look at the site, we may not understand what all trees or what all obstructions are going to shade the module, but the sun eye, since it takes an image and plots the whole year's sun's path, it can give you a clear indication of all the trees that are going to be there and disturb with the whole shading analysis. Right? Let's say, for example, this one is like if you look at this month, let's just look at December. You can see there is no shading for December in 12 o'clock, but whereas, sorry, like December is over here and June is over here. You can see that in June, May, and April, you don't have any shading from say 10 o'clock in the morning till 4 o'clock in the evening. Whereas in December, you have some shading after 2 o'clock and before 4 o'clock, and then you have a lot of shading because of this tree from say 10 o'clock to 12 o'clock in the afternoon. So what happens is this gives an idea whether this is a good site for us to go for solar, or whether we have to make a few and changes to the site. Say, for example, if the customer is okay with removing this tree, then we might have to remove this tree because it's definitely going to shade the modules for say about 3 to 4 hours in a day for almost 3 to 6 months in a year, which is not good for the whole generation. So this is the tool that used to help us um, with the whole shading analysis. But what happens is this tool is not a standalone tool. I mean, this is a standalone tool. You would have to have a tool in hand, let's say for example you have three members of the team who always are out there trying to do a site visit. You would have to have three different tools for everyone to do it and to share the information. For example, you do this analysis with Sanai, and then it generates a report that you could include in your energy estimation. But what happens is you would have to connect it to a computer, and then Solmetric has its own software to generate the report, and then that is what is used for the final design process. So in order to overcome this, we are looking at another tool called Step Robotics. So what happens is this is an app. So you can keep your own mobile, and then all you have is a lens that the Step Robotics provides. You can put that lens on top of your mobile, in the front-facing camera, and then it takes a similar image that we saw with sunlight. So it takes a similar image, it makes use of the GPS in your phone, and it understands where the site is, and it predicts the whole sun's path for the whole year, and then it gives you an instant report that you can, use for the final PVSyst design, or talking to the customer. Say for example, you're on site, you take a report using Step Robotics. It gives you a report right there saying that this is the shading loss you would have in the field, and then while you're talking to the customer, you're done with the shading analysis, right? You can talk to the customer and show him the report on his phone, on your phone, saying that this is the overall shading loss you might have, this particular site, and you can also talk to them about, removing few trees, or moving a HVAC unit, or any satellite antenna, or anything he has on his property, so that you are able to, provide him, say 2 or 3% more energy for the same system size that you're going to install on his property. And yeah, and this is also something we are looking at, and this would be good for anyone who does site visit often. We don't have to go and measure each and every obstruction for us to understand what shading impact it would have on the design. This would solve the whole shading analysis calculation in few minutes. That would take about an hour with other design tools, or measurements that we make in the field.
Okay, great, Ram. It was a pretty explanatory thing. We'll switch over to another question. So we'll
Okay.
move on to answering one question, that how one can get an expertise and switch over as a freelancer to avail the opportunities after getting expertise on these tools.
Okay. Okay. So I think I could talk a little bit about moving towards freelancer, how we look at projects, how to gain expertise on these tools. So what happens is, like when we learn a tool, let's say for example, when we learn a tool through any course or tutorials, we usually start with a test case, right? We take a design, or we go with a design saying that this is the tilt, this is the azimuth, and these are the modules we have, and this is how the system looks like. So we start with that. We start with a very basic design, and then we try to do that simulation in PVSys, and try to understand. Okay, this is how the report looks like. Now the next step would be, in order to complicate the whole design process. Let's say, for example, we have a project. Let's say the very first project that we try with PVSys, let us assume it doesn't have any shading obstruction, right? We try to do that, and then we get a report saying that this is the energy that the system would produce. And then what happens is we would have to understand a worst case, try a worst case scenario, saying that we have a tree right in front of the system, and then we try to estimate, or predict that system's energy with PVCs. We try to understand, okay, this is what happens when we have a tree, and this is the values that we need to change there in order to do that. Right? So what happens is, if we keep on trying the best case scenario in any estimation tool or any tool, we won't be able to understand all the features that are there within the tool. So what I would suggest is, always try to assume a situation where it is the worst case for solar or any tool, and then try to model that in a estimation tool, so that you understand, okay, these are the numbers we need to change, these are the walkarounds you need to do. And what I would suggest is, like, always try to look out for projects that are kind of very difficult to model in PVSys, so that we either try to look around for, I mean, not just PVSys or any tool, so that we try to find out ways for a walkaround, or any changes or any detailed changes that we would do, so that we understand where each and every button is located, or what are all options are there in PVSys, and things like that. So that would give us a whole understanding of the tool from point one to end of the tool. That is one step. And then what happens is, Once we do that, it kind of gives us a confidence to like talk to people, and there are tools out there. Sorry, there are platforms out there like Upwork and Freelancer, which where you can find a lot of opportunities with respect to design and solar in general. You know? So what happens is I use Upwork to get some freelancing projects now. And what happens is there are a lot of people who just look out for people who could help out with Helioscope or PVSyst for a very short term, or they might be looking for someone to engage for these particular tools so that they can have like a long term relationship with them for the design. So that is how we could move from being like an in-house designer and to a freelancer.
Great, Ram. So we'll have one more question. Manikandan from Saudi is asking that, like, what inputs you have taken while getting that PVSys report, like Azimuth, and like on the basis of only production, and if we'll take it in Northern Hemisphere, how it will change?
Okay. So what happens is in PVSys is a kind of hemisphere oriented. Let's say, for example, when we do a layout, we don't say if it's with respect to north or south, right? Since we are in northern hemisphere, when we say we like the projects in India, since we are in northern hemisphere, whenever we do a project, we try to move the modules towards. We try to keep the modules facing towards equator, right? So it's always going to be facing south. And what happens is in PVSys is you don't enter numbers saying that azimuth is 180 or azimuth is 185 or 180. We don't do that, right? PVSys understands azimuth value only from 90 to minus 90. So what happens is it keeps east as 90, and then south as 0, and then west as minus, sorry, east as minus 90, south as 0, and west as 90. So we got to move the numbers from northern hemisphere. We got to move the azimuth values that we have in our layout into a number that PVSys understands. Okay. Let's say, for example, we have let me open up a layout. Okay, so I have a layout in front of me, and I'm just going to zoom in on the section over here, system description, right? You can see that the tilt angle I say here is 10.4, and my azimuth is 186. So this is a south-facing system, right? Since the project is a northern hemisphere, my modules are facing south, and my azimuth is 186, and I have a pitch of 56 inches, and this is the rooftop is. Now what happens is I won't be able to enter this 186 within PVSys. So what I would suggest is you subtract. So since we are in Olympia, I always subtract 180 from whatever number we have. So what happens when you subtract? Let me explain this. So right. So this is going to be north, and this is south. And what happens is PVSys considers this one as 0, right? Perfect south for a project in northern hemisphere, this is 0, and this is going to be 9 minus 90, and this is going to be positive 90, right? This is with respect to PVSys. Whereas I have a project in here which is with respect to whatever design we do. Like north is 0, east is 90, south is 180, and west is 270, right? And my azimuth is 186. So what it means is this is not perfectly south, but 6 degrees off to the west. So my project is facing somewhere like this, and the angle I make with south is actually 6 degrees, right? And this 6 is what PVSys understands, right? So what happens is in terms of entering azimuth within PVSys, I would not enter 186, whereas I would enter only 6. Okay. Let's assume instead of 186, if my project's azimuth was say 150, right? What happens is 180 is perfect south, and 150 is going to be somewhere over here, and this is 90, and then I'm moving towards east, so my azimuth would be minus 30, and this is what I would enter in PVSys. So this is how PVSys understands the azimuth value. And what I do is this is how you visualize what PVSys does. But for a thumb rule, what I do is I always subtract 180 from whatever azimuth value I get. So for example, my azimuth is 186 over here. If I'm subtracting 180 from it, I end up with 6, and that is what I enter in PVSys. So if my project's azimuth, real-time azimuth was say 150, subtract 180 from it, I end up with minus 30, and that is what I would enter in PVSys, and that is how it understands the azimuth value. So, but whereas in Helioscope or any other energy estimation tool, they give you an opportunity where you can just enter whatever azimuth you have in the layout, or you have it in the real world. Say for example, this project is 186. In Helioscope, I can just enter 186, and I don't have to worry about if it's like southern hemisphere and northern hemisphere, because from the weather data and from the address, Helioscope understands whether it's northern or southern hemisphere, and corrects accordingly.
Okay, Ram, thanks for answering that. We'll have one more question from Mr. P. Shankaran. That is it economical to buy one of these software if you are a fresher in the industry?
So let's put it this way. It really depends on who we are engaging with. Like these softwares don't come cheap. At least PVSys doesn't come. It used to be, when PVSys started out and when they had like a previous version, they were selling all for like $300. Now a license costs you around $1,300. So what happens is that's like a one-time fee that we pay for the license, and it really depends on how many projects or what is your inflow. Say for example, you spend around $1,300, and if you're able to say for example take that money from doing previous designs within say 3 to 4 months in a year, then I guess the remaining the 9 months is something where you are able to see a positive inflow because of having a license to PVSys. But if you have like one project in a whole year, then I think it doesn't make sense to invest that much money into a tool. Whereas that's where we come to a conclusion, right? We have other tools. Let's say, for example, Helioscope. You have like a monthly subscription where let's say you have a set of projects coming in. Say, for example, you have to do like 100 projects in a month that has come up, like a new contract or something has come up where you want to do 100 projects, and you are going to do all those 100 in a month. So it's okay for you to get like a month's license, get the projects done, and then probably hold on without having to sign up for the whole year, and wait for the next set of projects to come in, so that you're not paying for months that you're not using Helioscope. So that is where a monthly subscription and annual subscription kind of helps you. And what happens is, like for me, since I'm doing PVSys on a very regular basis, it kind of helps me to have a license for myself. But sometimes if you don't see that sort of influx, then probably it might be good to hold off a little bit on getting a whole year license, and not having any projects to design.
Okay, thank you, Ram, for answering that. So we'll have one last questions from Mr. Prashant Singh. So he's asking that any application is available for solar string sizing calculation, string wire size calculation.
String wire size calculation. Okay. So right now there are a few spreadsheets that people put together. I've come across one by I think the company, the website was to string sizing initially, and they put out a couple of different spreadsheets where it starts with string sizing. You have to enter the site's temperatures and gives you string sizing, and then you can say this is the inverter's output current, and this is the junction box number of inputs per junction box, and things like that. It gives you a string size that you could actually change around. Say, for example, you can say do not exceed a voltage drop of 2%, and then gives you a certain string size, wire size, and then you can say it's like only 1% is allowed, then it gives you like an extra wire size for that particular design. But in terms of tools, there is not much out there. Either PVSys or Helioscope doesn't help you with wire sizing. If you have like a wire size, if you have a cable size, you can go and enter there, but it would not tell you what the wire size needs to be. So we would have to depend on some spreadsheets, that either we put together or it's out there, which one or two engineers have already put together and have made it available for people to try it out. So
Okay, Ram, thanks for answering that. We'll conclude the session with the overall opportunities that has yet to be created in solar sector in India and worldwide.
yeah. So guys, what from my experience, what I've seen is, like I'm working as a freelancer now. But what happens is when in order to try and build your portfolio, it's always good to have some engagement with the companies we are working now, so that you would work on multiple different type of projects, right? Like when you're working as a company, we try and move out for a lot of different opportunities. So you try to get projects that are like large scale ground mount, small scale rooftop systems, and then sometimes you might have like a system with a battery bank and on all those. So you get to work on multiple different projects, and that's where we try to and that's where we get an opportunity to sharpen our tool. So that kind of builds you a different type of different portfolio that you can gain expertise over. And with this, and the next part of what I've seen is with the recent growth and everyone's move towards green energy, there are a lot of opportunities, and even companies that are there, since the beginning of solar, even for those companies, when they have to go for multiple different projects, they are left with few resources, few in-house resources, so that they have to depend on freelancers or come out and get the help from external consultants to actually get get the project done. For example, there are a few companies I've come across where they have like an in-house design team, which is already working on few projects, but they have like a project that has come in where they need to work on or provide, say for example, 20 or 30 helioscope reports in the next week. So what happens is they are slammed and they kind of try and come out and get help from external consultants, and that's where I see, which is pretty new for the solar industry, because in general any mechanical industry we don't go out and try to get any help for such projects, but with the recent burst and number of projects that people are doing, I see a lot of scope in there, and definitely people are trying to go out and fetch the expertise out there. So,
Okay, thank you very much, Ram, for conducting such an explanatory webinar. So this was our first webinar, and we are planning to schedule it on every Sunday. So it will be on the advancing level that today we have explained on the basics of comparison of the software tools. Now we'll advance it a little bit, and we'll see that how integration and API tools work in such software or kind of. So stay tuned, and many congratulations that you have made it to the first initiative of India in solar webinar, and we'll be live and taking it forward. Thank you. We'll be ending it now.
thank you guys.